Assalamu alaikum, my dear students. I hope so you all are fine and you are enjoying good health. I'm your chemistry teacher Sundar Sanif, and today I will teach you chapter 3, periodic table and periodicity of properties. And as you know that it's a revision phase, so today we have to revise the topic modern periodic table and shielding effect. So first of all, for today, learning objectives. By the end of this lesson, students will be able to understand salient features of modern periodic table, shielding effect and its trends in periodic table. Modern periodic table. Students, as I told you in the previous lecture that atoms and different elements are arranged according to their atomic number in the modern periodic table. They are arranged in two forms. The first one is in the horizontal rows, which are called period, and in the vertical column, which are called as groups. So different elements are arranged in different groups and periods according to their atomic number. So we can say that modern periodic table is arranged according to the atomic number of different elements. The periodic table. In this periodic table, different elements are arranged according to their atomic number. For example, hydrogen has atomic number 1, so it has the very first position in the periodic table. On the other hand, helium has atomic number 2, so it got second position in periodic table. Like the atomic number for lithium is 3, for beryllium is 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and neon 10. So this is all about the atomic number. This periodic table is all about atomic number. Here, different elements are arranged according to their atomic number. For example, if lithium has atomic number 3, it belongs to first group and second period. Keep this thing in your mind that the outermost electrons which are present in the valence shell, they indicate about the group number, whereas a number of shell indicates about the period number. So this is how we can find the group number and period number of any element. For example, if lithium has one electron in the outermost shell, it means it belongs to first group. Let's see. Yes, it belongs to first group. On the other hand, in here the two shells are formed. It means that lithium is from second period. Yes, it is from second period. This one is first period and this one is second period. So this is how we can find the group number and period number of any element. Keep this thing in your mind that the outermost electron, the number of outermost electrons, they always represents the group number, whereas the shell number represents the period number of any element. Periodic table or the periodicity, it depends on periodic law. According to periodic law, regular variation or patterns of properties with increasing atomic weight. Both chemical and physical properties vary in a periodic way, repeating pattern. So we can say that according to the modern periodic law, the periodicity of the properties of elements are according to their atomic number. What are groups? The vertical columns of elements, it is also called as a family, whereas period is the horizontal row of the elements. So the vertical columns in the periodic table, they are called as groups, whereas the horizontal rows are called as period. So periodicity of properties means there is a continuous variation in the properties of different elements when we move from first element towards the next and when we move from one group towards the next. So this is called as periodicity of properties. Modern periodic law. The physical and chemical properties of elements are periodic function of their atomic number. Students, as I told you in the previous lecture that according to Mendeleev's periodic
law, the physical and the chemical properties of elements are the periodic function of their atomic masses. Mendeleev arranged the elements according to their atomic masses, whereas Moseley came and he arranged the elements according to their atomic number, and he also presented a modern periodic law which states that the physical and chemical properties of elements are the periodic function of their atomic number. So we can say that the periodic table nowadays we have, it consists of the elements which are arranged according to their atomic number, not the atomic mass. Blocks in periodic table. Let me tell you, here are 4 different blocks in the periodic table. I'm not talking about group, I'm not talking about period, I'm talking about block. So students, don't get confused between a group, period and a block. Group is actually the vertical column in the periodic table, it is called as a group. The horizontal row in the periodic table, it is called as a period. Whereas what are blocks? The first and the second group elements are called as S block elements. From fifth onward, they are called as P block elements. Whereas these transition metals, they are called as D block elements. And both these rows, they are called as F block elements. Elements are arranged into different blocks like S block, P block, D block and F block. Why they are arranged in different blocks? Like, if an element which belongs to S block, their electronic configuration ends with S, or the outermost electron will enter in S block. On the other hand, any element, if it belongs with the P block, it means that its electronic configuration ends with P block. P subshell means. So if any element which belongs with P block, its electronic configuration, the outermost electron will enter in P block, whereas same is the case with D and F block elements. Their electronic configuration ends with D subshell and F subshell respectively. It means that their outermost electron will enter in D subshell and F subshell respectively. Okay, so according to the electronic configuration, elements are arranged into 4 blocks. I am repeating: S block, P block, D block and F block. First and second groups are called as S block. From 5th onwards till 8th, they are called as P block. These transition metals are called as D block, whereas these lanthanides and actinide series are called as F block elements. So students, don't get confused between a group, period and a block. Elements in periodic table. In the modern periodic table, as I told you, that different elements are arranged according to their atomic number. Hydrogen is having atomic number 1, helium 2, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So you have to learn first 20 elements with their atomic number in atomic masses, but keep this thing in your mind that in the modern periodic table, elements are arranged according to their atomic number, not with according to their atomic masses. Still they have atomic masses, but in this periodic table they are arranged according to their atomic numbers. Periods and groups in periodic table. Students, as I told you that the vertical columns in the periodic table, they are called as groups. For example, this is the first group, this one is second group, third, fourth, fifth, sixth, seventh and eighth group elements. Okay, these are actually the subgroups which are called as transition metals. So How can we define groups? The vertical columns in the periodic table, they are called as groups. Okay, for example, the first group consists of hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So these are the members of first group. Students, keep this thing in your mind that whenever we have to find the group of any element, we will look that how many electrons are present in the outermost shell of that element. For example, if any element will have 3 electrons in the outermost shell, we call it as it belongs to third group. On the other hand, for example, lithium has 1 electron in the outermost shell, so we can say that lithium belongs to first group. Okay, for example, magnesium, it has 2 electrons in the outermost shell, it means it belongs to second group. So this is how we can find the group number of any element. Okay, I'm repeating, the outermost electrons, the number of outermost or the valence electrons, it tells us about the group number of that element. Period. The horizontal rows in the periodic table are called as period. For example, the first period consists of hydrogen and helium. Second period consists of lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so basically the horizontal rows in the periodic table, they are called as period. How can we find the period number of any element? Keep this thing in your mind that the shell number will tell us that this is the period number of that element. For example, in the electronic configuration of lithium, 2 shells are formed, K shell and L shell. It means that it belongs to second period. So have a look. Yes, lithium belongs to second period. Okay, so we can find the period number by the shell number of that element. Horizontal rows in the periodic table are called as period. Shielding effect. Shielding effect is also properly known as atomic shielding or screening effect. What does this shielding effect means, students? As you know that nucleus has positive charge and electrons, they have negative charge. And there is always a force of attraction between the nucleus and electrons. Why there is force of attraction? Because you know that different charges will always attract each other. So the electrons which are present close to the nucleus, they are more attracted by the nucleus. Why? Because they are present very close to the nucleus. But you know that different electrons have negative charge, and you also know that the negative charge or the same charges will repel each other. Okay, so we can say that the shielding effect is the reduction in force of attraction between the nucleus and the outermost electron due to the inner electron. It is called as shielding effect. Okay, the shielding effect describes the decrease in the attraction between an electron and the nucleus in any atom with more than one electron shell. Or we can also define the shielding effect as the reduction in the force of attraction between the nucleus and the outermost electron due to the inner electrons. It is called as shielding effect. Look at here, where the positively charged nucleus is present, and this is the outermost electron. Nucleus will definitely apply the force of attraction on this electron, but the electrons which are present in the inner shell, they will repel this electron away from the nucleus. So the reduction in the force of attraction between nucleus and the outermost electron due to the inner electron, it is called as shielding effect. Shielding effect usually remains same, or it usually remains constant when we move from left to right in a period, whereas when we move from top to bottom, shielding effect will increase. Why shielding effect will remain same? when we move from left to right in a period, because the electrons are going to be added in the same shell. Okay, so shielding effect will remain same, but when we move from top to bottom in a group, shielding effect will increase. Why it will increase? Due to the increase in the number of shells, or due to the increase in the number of inner electrons. Okay, students, keep this thing in your mind that shielding effect remains the same, but the effect increases across a period from left to right.
So students, here is your homework. You have to write the answers of these questions on notebook. Your question number 1 is differentiate between groups and periods. And second question is define shielding effect. What are the trends of shielding effect in modern periodic table? This was all about today's lecture. Still, if you have any question or any query, you can ask me during our Zoom session. I will clear your concerns by using video slides and by using whiteboard. Till that, take good care of yourself and everyone else around you. Best of luck, students. Allah Hafiz.